Hello, dear students. Today we're going to do Proposition 40, Book 1, Proposition 40. Equal triangles on equal bases and on the same side of that base, not this way, but this way. Equal triangles on equal bases are in the same parallels. Okay? Here we have given two triangles which are equal to each other. It's given that they're equal and that they are on equal bases. We don't know anything about their angles or the sides or anything like that. What we're going to have to prove now is that this triangle and this triangle are in the same parallels, that they're going to be in the same parallels. And when you connect the apexes, that these two lines will necessarily be parallel. We're going to use a reductio ad absurdum, okay? So if they're not in the same parallels, some other line coming from this point or this point is going to be parallel with this. Let's start off by, let's use a little black line. Let's start off by saying, okay, let it fall this way. Okay, now this and this are parallel to each other. So we're granting Mr. Smarty Pants' position, okay? This is a reductio. Our imagination tells us that these are parallel, and we say, okay, they're parallel. And he, being a guy who really wants to know, say, how do you know that? Let's doubt for a little bit. Okay, well, if that's not parallel to that, some other line is parallel, either on this side or on that side, right? Let's do it on this side. Okay, great. Let this be parallel to that. And we're going to find that it's going to reduce to an absurdity. When you grant a false position, it's going to reduce to an absurdity. It's easy to see in math, harder to see in philosophy. Okay, so these two lines connect at a point. Let's connect these 2 points. Okay, now we have a triangle here. And we have a triangle here. And they are on equal bases and in the same parallels, okay? Remember from our bag of knowledge, we know that triangles on equal bases and in the same parallels are necessarily equal to each other, okay? So this triangle here is necessarily equal to this triangle here because they are in the same parallels and on equal bases, okay? So this is equal to this. But it was given that this is equal to this. So here we have two things, two triangles equal to the same triangle, so they're necessarily equal to each other. But this is also the whole of this. This is a part of this. We know that the whole is greater than the part. That is to say, in this case, obviously unequal because it's greater. But it was proven that this is equal to this. So now we have this being unequal to this and equal to this at the same time, the same respect. Baya! An absurdity. So the thing we granted, that this is parallel to this, must be false. The same thing would happen if we said let the parallel line fall above it. Then all you do is you connect to, let's see here. Let's do it now for once. You make, you just continue this here, say, and this here. So now this triangle is equal to this triangle, but this is a part of it, so it's also greater than this. So here you have given that this is equal to this and proven that this is equal to this, therefore they're equal to each other, the whole equal to the part, just like we saw before, that is to say unequal. So here now we have this being equal to this and unequal to this at the same time, in the same respect, okay? So, which is obviously absurd, therefore saying also that this is parallel to this is false. Well, if it's false to say that this is parallel and this is parallel, something in between would have to be parallel. And you're going to find that anytime you don't choose this line, that is the line that connects the 2 points of the apexes of the original triangle, anytime you don't choose that, you're going to have an absurdity. So the only way you can not have your absurdity is by choosing the last possible option, that when you connect the 2 apexes, the 2 triangles are in the same parallels, okay? So, therefore, we have shown that given 2 triangles which are equal to each other and on the same base and on the same side of that base, not this way but this way, they're necessarily in the same parallels. Quod erat demonstrandum. Thank you so much. Bye-bye.